right? I think you're the one getting us started, Dave.
My schedule says summary from day one, reproducibility, speaker, Deborah.
Yeah, we just did this, which was do you have any questions?
Okay, all right. Well, let me get my slides then. Cool. So today we're going to go through Git and GitHub to start. Hopefully familiar terms, and it's okay if you're not super comfortable using these things yet. But we got a little bit of an introduction yesterday, so hopefully you have some idea of what they are. So Git and GitHub are used for version control. Version control is primarily Git. Collaboration, primarily GitHub. I have citation here, and we saw yesterday that you can't exactly create a DOI from GitHub, but you can link to Zenodo and enable your code to be cited that way. All right, so why do we need version control? I was pretty terrible about this during my PhD, which I regret very much now. If I could go back and talk to my former self, I would try to convince myself to do some version control. So what I did, and what I hope you're not doing, is just have kind of a random assortment of files and directories that I use from time to time that exist locally on my computer. And then I kind of I don't know, some random interval, decide to back them up on an external hard drive or push them to Google Drive somewhere so I don't lose anything, but not a lot of control over um, which version is latest, which has been edited for this or that purpose, which is, kind of the most complete version. I did not do any of this during my PhD work, so I encourage you to think about version control, and hopefully, if you're in this course, you already have some idea of that concept. Um, so tracking changes, I think everybody at this point uses some Google Docs from time to time, and that's a great way to think about tracking changes. You work back and forth with your advisor or with collaborators. People suggest changes. Um, the person kind of in charge of the document accepts or makes some revisions based on the suggestions. Tracking changes works in a somewhat similar way in Git and GitHub that we'll talk about. Collaboration, so all of your code being posted to GitHub enables people to review your code, look at it, make suggestions, make suggested improvements, handling requests for bug fixes. And then lastly, we talked about reproducibility a little bit already. So putting this code up where other people can get it makes your scientific workflow reproducible, so long as you're including your environment and the code you use to arrive at your results. Okay, so what is Git? Git's been around a while. Git's been around a while longer than GitHub. So this is distributed version control. So the idea being that there's a master copy somewhere. There are other remote copies elsewhere. And you can exchange between the remote and master copies. So generally, we think about this in terms of there being a directory. So there's, when you call it on your local computer, you'd call it a folder or a directory. And when you put it up on GitHub, you might call it a repository. But in either way, you're talking about a folder of many files that can have subfolders. Um, you're able to track changes in your code and your files. So when I have a local copy of my repository, I can make changes to individual files and save those changes. We call this a commit. So when I make changes to local files and I decide to commit those changes, I've now established a new um, I don't want to get too confused with terminology. I would have said a new version, but version might be a mistake in choice of terms there. But this commit is an updated copy of your local files. You can push those to the master. Now your master is up to date with your local version. So many people can work at the same time on the same repository, have their own local copies. They can pull from the master. They can make local changes and commit those and push back to the master. So this can all this can be on your own with Git. So not collaborating yet. Once we involve GitHub, we involve more collaboration. But the aspect the underlying piece here, the software that's running before you start thinking about collaboration with GitHub and things up on the cloud. Git is enabling you to create versions through time. You can also create branches, so you can have multiple working copies of the same set of software that you are doing things with that you might want to try something out. Maybe I want to try a new model and test it out. And I see that it doesn't work so well, so maybe I kind of just set that branch aside and go back to my main working branch and move on from there. But Git allows all of this version control, so it's easy to see how you've made changes through time and keep track of what's most up to date. Deborah, feel free to hop in here. I see you making looks now and again. I'd love
Oh,
to have extra input.
no,
Yeah.
no, sorry. I'm trying to reorganize Windows so that when I have to share my screen, you don't get my beautiful proposals.
Okay. So basic Git commands. So if you're doing Git from the command line, you'll be using these commands directly. But it's also useful to know these commands because most of them are reused in GitHub. So git init, this initializes a repository to be used and versioned with Git. Git clone, this is to copy an existing repository. So you'll see this feature when we use it with GitHub. You can copy somebody else's repository and start from where they left off. There are also templates on GitHub that you'll copy in a similar way. Git add, this is to track changes on a file that's in your repository that is not currently being tracked. So you have a bunch of files in a certain folder that you're tracking via Git, but you may not track all the files in that folder. Git add allows you to track a new file that wasn't previously being tracked. Git commit. So I started describing this in the previous slide. Commit is updating your current version. It's saying that I want to kind of save this point in time. I want to save the changes as they currently sit and make this quote unquote new version of the software without officially versioning it. That's a separate topic. Git push. So moving things back up to GitHub and Git pull. pulling from the master that's up in the cloud. Okay, so what is GitHub now? So this is another layer on top of Git. This is the cloud aspect, the collaboration aspect, um, in some cases, kind of the social and community aspect around a software package. Um, so this is where you can host your code live online. Um, this is also the place that people will access your code. So if they're trying to interact with your code, they're trying to collaborate with you, or they're trying to just use your code. This is where they're going to access it. Um, so this is also the aspect that facilitates pull requests, issues, and discussions, which are features of GitHub in particular. So these terms are specific to GitHub, and I'll go into these in a little more depth. So a pull request is something I had heard the concept of for a very long time before I actually knew what the heck it was. So a pull request is the way you interact with someone else's software and suggest changes. I actually come fairly close to making the changes and just awaiting their approval. So a pull request works via a fork. So fork is very similar to a clone that I mentioned before. A clone is a copy that is now separate from the original, whereas a fork is a copy that is still attached to the original and still in relationship to the original. Um, After you fork a repository, you are free to make changes to it. Um, Note that those changes are not on the main branch that's live on the original repository, but is active in your own space. And then you can request the original owner to merge those changes. So this is the way that you make additions to someone else's software. Say maybe there's a Python or R package that you've written an extra function to, that fits really nicely within the scope of that package, but that capability doesn't yet exist in the software. And you kind of already use this function locally, and you've decided that it would make a nice addition to the software package. This would be a nice avenue to add a function to an existing software package. It's a way to fix bugs that you figured out how to fix on your own. And it's just it's a nice community tool for collaboration. Issues. So this is sort of a step below a pull request. This is the way you do this is the way you do the work that you might want to do in a pull request, but you don't really know how to do it on your own. So I find a bug in software and I don't know how to sort it out for myself. So when you find a bug, these are the steps that I try to go through myself and hope others are going through. First, are you sure it's a bug? Have I just done something wrong? Is there more documentation that I can dive into? Maybe I've just, not formatted my arguments to a function correctly. Maybe I've entered an argument and just misspelled it. Make a mistake like that pretty often. Secondly, other people have probably experienced this before. So just entering your error message into Google or Stack Overflow is usually a pretty good place to start. Entering that message as generically as possible. Go ahead, Deborah.
I'm going to say you also want to enter that in ChatGPT or Claude.
Oh
Usually.
yeah, that's a great resource as well. Yeah, I've been using AI more and more for code, at least to get like a template or something to start with. But yeah, it is pretty good at helping to sort through bugs. It seems to have been trained on just an enormous amount of code or Stack Overflow because it seems to get these questions pretty well. Um, Okay, and then last for a bug report, how can someone else on a different machine reproduce this problem? So if you've gotten through, like you're sure it's a bug, you can't seem to find anyone has solved this issue, Google Stack Overflow, Chat GPT can't solve your problems. It's time to write up an issue. And in writing that issue, you want to make sure that somebody else can reproduce this bug. I'm going to talk about that in a little more detail on a different slide here. Um, but then the last point of issues is feature requests. So this is just a community feature of issues. I'm using words in multiple ways that I shouldn't be. So this is a way that people use issues to request new functions in a software package, for instance, new functionality in general out of software. Issues are a reasonable place to do this. We might also do that in the discussion forum, which I'll talk about in the next slide. But before we do that, let's talk about a reproducible example, because in general, as you're working more and more with code, you're gonna make bug reports. You're gonna ask people to help you solve problems in software, and creating a reproducible example is a really important part of this. So when you come across a bug, you may be deep inside of your own code base. You may have, drawn in megabytes or gigabytes of data and be in the middle of running something fairly complex. The first thing to do is get to as minimal an example as possible. So I want to get the same bug that I'm experiencing with a smaller amount of data, ideally, kilobytes of data or smaller, something that I could just write out in hard code on my screen, or drawing in a very simple data set. As few lines of code as possible, as few libraries as possible, as minimal in all those ways as you can. It still needs to be complete. So someone else drawing on this needs to be able to reproduce that bug by running exactly the lines of code you have. So as minimal as possible while still being complete. And then lastly, reproducible. So make sure you're running this. Ideally, you have some separate sandbox to run this in to test the code and make sure that your reproducible example still produces the bug reliably. Okay, so connecting Git and GitHub here more concretely again. So Git is local version control. You probably will not need to write command line Git because there are nice user interfaces that overlay on top of Git to allow you to interact directly with GitHub. GitHub Desktop, for instance, allows you to interact directly with GitHub without using any command line code in a nice user interface. RStudio also has an option to interface directly with Git and GitHub without doing anything from the command line. Again, GitHub is a remote repository, both for backup and collaboration. So we just talked about some of the collaboration aspects, but also very usefully, it's just a place to provide a backup for you if something goes wrong in your local repository. You can draw again on that backup. You can start from wherever you last pushed to GitHub. Synchronization through push and pull commands. So synchronization as in you're working or you're collaborating on a project with multiple people. We have perhaps multiple branches of the same repository because we're working on different aspects of the code, pushing and pulling at different times without overwriting each other. So there's maybe more to this than, I would like to work on file X and you're going to work on file Y. We can create different branches for different projects. So I want to add um, a new function to our package. I'm going to create a branch with that specific goal in mind. It's going to require working on files X, Y, and Z. And when I'm done with that new package, I'm going to merge that development branch with the main branch of the project. Um, this working with Git and GitHub allows you to, maintain version control on your own computer through time, but also collaborate in this way where I have clearly delineated projects, you know, attached to a specific branch, and I'm able to collaborate that way and clearly delineate the work. Sharing code in science with GitHub. So GitHub is a primary place to deposit scientific workflows as well as software packages. We already mentioned a little bit that you can connect with Zenodo to create a DOI and make this citable. There are options on GitHub for private repositories. I think that if anything, people are maybe creating more private repositories than are necessary. It's I think it's rare that someone is coming to take the credit for your partially developed code that is not yet ready to share. So it's my personal practice to just create public repositories for everything that doesn't have a security concern. So if I'm working on a project that is related to web development and there are security concerns, as in sharing the code will expose the underlying architecture of how you can get root access to my server. that's maybe not something I want to share, but outside of deep security concerns, I don't have any use cases for creating private repositories. I'll also say that public repositories give you access to more tools. A lot of the tools that are freely available through GitHub are super convenient to use and just not available for private repositories. Collaboration through pull requests. I mean, collaboration in general is obviously a little more complicated with private repositories. I already went through collaboration with pull requests. Yeah, obviously open science and fair principles as well. This is all of your code has to be public to be open or fair. So that goes without saying. Okay, so GitHub and GitHub Desktop. So GitHub Desktop is a GUI for your local interactions with GitHub. So GitHub is the online cloud repository. So this is where you're pushing your code to the cloud. You're interacting with a GUI that has some of these collaboration features. And all of that, again, is overlying Git, the version control aspect. GitHub Desktop allows you to interact with a GUI, so you do not have to do any command line Git to do all of your local version control. So you can push and pull from GitHub Desktop. You can do all of your commits from GitHub Desktop. You can open files and edit them from GitHub Desktop. For me, I open them from GitHub Desktop, and that opens something in Visual Studio Code, for instance. This is all distinct from the GitHub website, which deals with the remote version of your code. I don't use GitHub Desktop that much myself. I tend to use Git command line, which you definitely don't have to use. It just gives you more granular control. Um, I also use GitHub from RStudio directly. If you are an R person, using GitHub from RStudio is a pretty nifty tool. Deborah, are there any Python specific things that I'm not mentioning here?
Not Python, but VS Code will integrate too with GitHub, so you can use that. So a lot of the IDEs are gonna integrate with GitHub, so you can do it. You can also use GitHub Copilot in there, which is gonna help you.
Hmm.
Uh, but I personally tend to use GitHub Desktop, and I think it's just what I'm used to. So I
Yeah,
think
I think that's what it comes down to.
that, yeah.
GitHub Desktop, I will say, is quite intuitive. I don't use it that much, but when I do hop back into it, it is not difficult to wrap your head around. All the everything is kind of right there for you. Um, yeah, I mentioned before about linking your work and making it citable on GitHub. This is generally done through Zenodo. That's probably the most popular way to do this. Um, I think Deborah mentioned some other tools that are available as well, but Zenodo is the only one that I ever use. Um, in addition to linking your code to Zenodo and making your code citable, um, we're also going to make a detailed README file which explains what your code base is and does. We will create a license file, which we talked about a little bit yesterday. Um, we will have all of our metadata, um, and we'll create a citation file. Citation files on GitHub are pretty nifty. They enable people to create citations for your code. The GitHub formats them directly, so you can create a BibTeX or I forget what other format. BibTeX is the one that I use and I'm familiar with, but GitHub will format the citations for you. Okay, so just the key takeaways here. Git helps with version control, helps you keep track of all of your files, what the newest iteration you're working on is. If you want to do a little sandbox, you can create a new branch and try something new and set it aside and never come back to it again, or eventually delete it when you remember it exists, without getting confused about which is your latest, most up to date, and development ready or production ready version. Um, GitHub enables the sharing aspect of all of this. So you share your code online. People can copy that entire code base. People can interact with it either by forking the repository and creating a pull request. Maybe they're suggesting some changes via issues. They can report bugs via issues. And you can have a community discussion as well, which discussion is a little more for community collaborative projects. So talking about the direction of projects, talking about the scope of projects, big picture sort of discussions are similar to issues, but more big picture focused in my mind, more open-ended. Key Git commands to remember. So commit, commit is, I want this to be a saved copy. I want my stamp right here in time of this particular set of files works in a way that I want to come back to later. Um, pull pull is pulling down from my remote repository up at GitHub. Push is pushing back to that remote. So I've got a version saved up in the cloud. I'm interacting with that version via push and pull. And then, yeah, just keeping in mind the importance of collaboration and citation. So this is all part of open software development, FAIR principles, keeping your code freely available, accessible to people. Yeah. Questions about Git and GitHub. Where are people with Git and GitHub? Do you use these tools? Is this how you manage your version control currently? Do you share via GitHub?
I'm personally not the best with version control as of now, hence why I'm in this workshop.
Yeah.
So I'm excited to be a bit more rigorous for it.
Yeah, I think I've kind of used it as a place to kind of put everything when it was done and I needed to create a Zenodo citation for submitting a paper. But I think especially if first thing I did was just create like simple Python R scripts that you could even just change like on GitHub itself. And so definitely something I should really better at is kind of especially like some kind of command line, just doing that all from um, my yeah, just doing better overall management like you've described.
Cool. Okay. Well, it sounds like we're we're in the right place then. Um, so I personally started in a similar place, just putting stuff up to GitHub once I was ready to share it, and slowly worked my way towards better version control as I was building. And yeah, we're gonna do some exercises to gain familiarity with Git and GitHub. Um, I've got a little document for specific resources for R that I'll share. Um, and then yeah, we've got a demo that we'll go through that kind of shows how to do all of this. You'll get a little practice with it. Did that answer your question, Kurt?
Yeah, exactly. Yeah.
Oh, cool.
Yeah, so what we're gonna do over the next like 2 hour and a half, I guess, is go through essentially a short demo, and it's gonna be an overkill for what we're gonna be doing, but it's just to actually show you how those tools work, and how you can use them, like use cases and so on and so forth. But you'll see in a lot of places it's going to be, why didn't you do this directly on GitHub? And yes, we could. It's just showing you exactly how you would do it for a more complicated case, essentially. But I think we can keep everyone here. What I would suggest is make sure you have all the materials from yesterday ready. So have your Python code. You should have a readme.md somewhere available. And most importantly, a GitHub account. Do you all have one? Okay, so let's do this. All right, I'm going to share my entire screen on this so that we can go back and forth. The thing with GitHub to remember is there is many ways to, well, I hate to say it, but skin the same cat. And so I'm going to show you how I tend to do it. Dave chimed in. If you use it differently, you'll see people using it differently as well. It's just whatever you're most comfortable with. So I know a lot of the students that I work with, they do it directly from VS Code. I tend to use GitHub Desktop a lot for lots of reasons. And I also actually tend to use GitHub itself because some of their GUI avoids some of the problems that I've had before when you're actually not really thinking like how things are actually like the movement of things. All right, so can you all see my screen, and it should show you github.com.
Yep.
Okay, so first thing is if you go to your account, click on your little profile, you can go to your repository, and it should actually give you a list of what you already have. This is the one that we're going to try to reproduce, and I'll show you how to get to it. But just for fun, I'm going to open it. And let's say that you really like my README, you really want to reuse my code, you really want to do anything, like you just want to be able to reuse, you can actually fork it. So for you, you would be able to see some, well, yeah, you would be able to fork essentially that repository to your GitHub account and be able to work with it. So that's a good place to start if you actually want to work on somebody else's code, you want to improve on it, or you're actually contributing to somebody else's code. So that's how you actually can copy somebody else's repository onto your own, is by forking it. There are also templates, as Dave mentioned, that are already done on GitHub that you can access and fork in the same way. So I tend to fork a lot when I do website development. You can actually host website on GitHub. So the Leapfrogs platform, for example, is on GitHub. And so it allows essentially being able to reuse what somebody else has done. Everything is set up for you, and you're actually just making it work for your own application. But in most cases, what's going to happen is you want to share your science and you need to create a new repository. So click on New. And essentially, you can choose to have a template in there or no template. So if somebody gives you a template for something like this, you can actually reuse it or basically start from scratch. So we're going to start one from scratch, and then you just give it a name. So name it something that is useful for you to remember, but also that you can actually type pretty quickly and pretty fast and without typos. So that's up to you. I think I called this one call visualization. You can name, repository names have to be unique within your own account, but it doesn't have to be unique on GitHub. And then you can have a description for it, and that's going to basically give you a really, really basic sentence that's going to show up on your GitHub repository, and also is going to populate a README for you. Good idea to have one. I know it's optional, but it's one of the things, just like remind you why you created that repository as you go. And then you can actually choose if it's public or private. So public, anyone on the internet can see this repository. As Dave mentioned, it allows you to use more tools like Zenodo to link directly. And you still choose who can commit to your code. So it's not because it's public that everybody can do whatever they want with your repository and, work with your files and so on and so forth. They can read it, but they don't really have write access, essentially, unless you say so. Private, nobody can really see it. You choose who gets to see it. You can add collaborators, things like this. So public versus private, I would say use private if you're really at the beginning of a project, but you really want to use the version control of GitHub for a little bit. But it's really not something you can show to anybody. You don't want anybody to reuse that work, or it really has like results from a scientific paper and you're not really ready to share it publicly yet. I would say keep private. Just remember that a lot of the tools that we're going to talk about won't be available to you until it gets toggled to public. Initialize this repository with a couple of things, the README file. So usually I just say add a README file so that it's there, or you can do it later if you want and commit it. Git ignore. So that's basically ignoring when you actually make changes on your computer to some files, it will ignore and not push those files to GitHub. And there are many templates for this that you can use. I tend to not use templates. I tend to not use git ignore from the get-go. I just add it later on. But things that you don't want to see, if you're using a Mac, there is that .ds store. You don't want to have that on your GitHub repository. It's a hidden file on your computer. If you're using Jupyter Notebook, they store the checkpoints and the virtual documents. That's not something you necessarily also want to have on your GitHub. So you can actually add those files one by one to a git ignore file. And what's going to happen is every time you try to push to that repository or commit, it's going to ignore that file or ignore changes to it. And then choose a license. So we talked about licenses yesterday, which one's the most appropriate for your work. If you're not really sure what to use, they do have an help here, learn more about licenses. I personally tend to use Apache 2.0 for a lot of my work because it still gives me credit, still gives me a lot of uses. It still has a as-is kind of warranty, but it's not like a free-for-all, essentially. So it's going to depend on, again, it's going to depend on what you're trying to do with your code. And then you can say create your repository, and it will actually create the backbone of your repository. So this is what I did for this one a couple of days ago. But essentially, once you've done this, you'll see that the description will show here in your about. It's also going to show where the README is. It's going to show you the license, some activities, and so on and so forth. And then the main part of where your files are is going to be into that area right here. And when you create your repository, you should have the README, the license, if you put one in, and that's about it at the beginning of it. And then the README actually shows people what they can and cannot do with your code, what it is about. Essentially, it's kind of like explaining to other people what your repository is about. Different ways of writing READMEs. I would say at the very minimum, have a short description of what it does. If you want to put citations in there, that would also be the minimum if you're using data from other people. Things like this. There is also information about how you can run the notebooks, how you can see the notebooks, things like this. So you can create a template for yourself as well and reuse it. I tend to do this quite a bit across my own. They kind of all look the same because I have a templated README and I just change the information from one to the other. And I left some things blank so that we can actually do a demo today. So that's on purpose. But once you've done this, what you can do with the code is essentially put it on your computer by cloning it. So you can use git clone from the command line, or you can say download the zip. And if you do this, it means you just want to use somebody else's code. You really don't want to reuse, you don't want to commit, you don't want to work through GitHub with it. It's just going to be a temporary local copy for you. Or you can say open with GitHub Desktop. And if you do this and you have GitHub Desktop open on your computer, it will actually get you to GitHub Desktop and actually help you through the steps of cloning it on your own computer. Once you do this, what's going to happen is, so depending on how you organize your computer, but I have a GitHub folder in my documents. And then each of my repository now appears as a folder in that GitHub folder. You have a choice. You don't have to do it this way. I tend to do it this way just because it's easier and at least I know it's all of GitHub. So you can see the files of core visualization, they're on my computer. And so I can, interact with those files like regular files on any of your like favorite applications. So for IPYNB, using Jupyter Lab and so on and so forth. Questions so far?
So if you modify a file in this GitHub desktop app, then
You mean
and you
on my computer, right?
and then you save it. This doesn't push it to the main remote repository.
Correct.
Okay. Commit and then push.
Then you have to commit and then push. Yes. So
And
I
if you
can do something, I'll show you what it does. So let's do the README. Let's remove my, and I save it. Now in GitHub Desktop, you see that the README has been changed. This is what that little orange box is about. It's saying the file has changed. And if I click on it, it shows me what I changed.
Okay. Yep.
And then,
But
oh, go ahead.
so let's say you're in the process of working on your research and you do have to change sentences like 1,000 times a day. When will you actually commit and push? Is it at the end of the day when you finish your work? Is it when you wrap things up? When would you actually do it? Because doing it every single time doesn't make sense.
Good question. Well, that's a personal thing. I usually do it at the end of the day
Okay.
so that it saves somewhere on GitHub. And this is coming from, a few years back, I was working at the airport and I had to get on the flight, basically put the computer in, something happened to the computer in flight, and like a cable got loose, so I couldn't reopen my computer on site over there. And I was very happy to get the GitHub copy on another computer that I could borrow for a few days. So, there are other ways, obviously, to save files, but for me, I do it at the end of the day just because I'm being paranoid now about closing my computer and not being able to reopen it. The reality is you could actually commit because you've made like huge progress and you want to commit this to memory and push it. It could be because you want to create a new branch because you want to try something new, but you don't want to do it on the main, things like this. There are many reasons you want to do it, but I wouldn't do it for every sentence. This is, again, like what we're doing today is an overkill just to show you how it works.
Okay, yeah, makes sense.
And then essentially, if you see something green, it means it's a new file. And if I don't want it, what I can do is click right and say ignore file, and it will add it to the git ignore directly. And if I do this, it's just going to create a git ignore for me. And from now on, that file will be forgotten, essentially. And you can see that I have other files that I don't want added to my repository. Does that make sense? And then usually what's asked is a summary of what you've done. So I don't know, I'm going to say fix typo in README. You want to write something that's going to help you, like, remind you of what you've done. So it's a good idea to have a short description of what you've done here. So let's say, I don't know, you're done with one part of your workflow and it created a figure. You might want to actually tell yourself, hey, I've created that figure in that particular commit. So I could say, change the README file to make it easier to read. Yeah. So then when I commit, as Dave mentioned, right now, it's basically saving on my local copy that it's committed. And if I actually want to put it on GitHub, I would have to say push. But because I probably made changes directly on GitHub, I have to pull first before I can actually push back. So it's pulling, and now everything is synchronized between the two. So I can push. And you're going to ask me what happened if there is a conflict between the two files. And that's what GitHub is really good at. It's going to tell you what the conflict is. You can open it, for example, in any editor for your file and then resolve the conflict before you can push. And the idea here is to avoid for you to overwrite work if it's conflicting, so that you get to choose which part of the work you want to keep. And then if you go to GitHub now and refresh, it tells you now that a minute ago, I changed that file and it's going to reflect the changes, like we lost the comma. So the reason you want to write a good enough description is because, see, now it says I had 17 commits into that branch. I can go back. That's the history of what happened. And so basically every time I write a description, it actually tells me what I did. And so it gives you an idea of what you've done and where, if there is a problem, where you want to go back in time to see what was changed. So just to give you an idea, before fix typo in README, if I click on update Docker file and I say browse files, it's going to get me back to that commit. And so I can see what the file looked like before I change anything. So you can always go back, essentially. It versions everything you've done. So if you're not happy about something, you can always go back. That's the advantage of it too. Any questions?
Sorry, if you go a bit up in the repo, up again, up. Yeah. Oh, okay. Where do you put the DOI? Ah, the DOI is in the README. Okay. It wouldn't be in the about. Can you put it in the about?
In the what?
In the about on the
You can.
right?
So if I click, let me go back to my main branch. If you click on about, you could put it in that description.
Okay.
You could actually, if you write the entire DOI URL, you could put it in the URL. You can create topics. You can do a lot of things like this. We'll go through how to link to Zenodo in a minute after we do some more stuff with GitHub.
That's what I was trying right now. But perfect. Thanks.
Remember that it's also attached to a release. So the release is available over there, that side panel that you can click on.
Yeah. So I'm going to go over release in a minute. Okay. So when do you want to create essentially branches versus committing directly? That's up to you. So if you're working with somebody else's code, it's not your code, and you just want to add to it progressively, then definitely create a new branch so that you don't really, mess with somebody else's code. I mentioned earlier that you don't necessarily have the right to write to somebody else's repository. So you might have to fork it first and then basically do a pull request to be able to merge this into somebody else's repository. Or even if you have access to that repo, but there is like 6, 7 people working on it, you always want to use branches so that you actually don't conflict with somebody else's work. So that takes a little bit of organizing. And how you actually organize yourself and make sure that, people are working on something and basically you're announcing to the world that you're working on something is by creating issues. So if you're alone in your repository, it's a little bit of an overkill to do this. However, I tend to do it so that I keep track of the things that I actually have to do. So if you have a to-do list somewhere on your research, I have to write this code, I have to do this. You can actually do it through issues in GitHub as well for yourself. So it's not just you have a bug and you want somebody else to fix it. It also helps you kind of get organized. So to open an issue, even in your own repository, you go to issues. And then you say, I want to open a new issue. And I want to say, add instruction on how to run the code on a local machine. And then the README has a title for it, but no text. Add it. So again, great for notes for yourself. Like I use it as a to-do list. It works. You can assign people. So if you're working collaboratively with people, you can actually assign other people. Right now, I'm the only one on my repo, so I could only assign myself. You can actually create labels for it too. Is it a bug? Is it a problem with documentation? Is it an enhancement? Is it a good first issue? If your code is meant for other people to contribute to it, that's a good thing to say to people, hey, this should be easy to do if you want to get your feet wet with it. Use this. We need help with this. Like we don't have enough people to really fix it. And you can actually create your own labels if you want to. So it could be I need this for a publication or something like this. Or you could actually say, hi, this is Mazakin. You could actually say something about like it's a visualization problem or things like this, and that you're free to actually put any label that you want on it. And then you could also assign it to project and milestones, and I'll go over this in a minute. But essentially, if you're happy with your issue, you just create it. And now it's going to tell you what the issue is and what you need to do with it. So I can show you what it does on a bigger code base that we're working on PaleoClim. But basically, we have issues that other people or we open, depending on what we're working on. We assign who is going to be working on it. And it allows us to keep track of what people are working on, who is working on what, and essentially making sure that we're not duplicating work or we're not reproducing work and that things are actually taken care of. But see, we have things like team hackathons, we have our own like tags to actually signal when something is going to get done. So good so far? All right. So one of the things with GitHub that you can do too is that it's a tool for collaboration. So if you're working with a lot of people, what you want to do is also indicate who is working on what and when. And also what milestones you want to reach, essentially by what date. Those are two things if you're working, like even in science, right? Your advisor might say, you have to get me that particular result by June. It allows you to actually put a milestone in June. I need to have X. And then you can put all the issues that goes under X in one place, and it allows you to see what you're working on. So to do this, two things to do. The first one is you can open what's called a project board. So if you click on projects, you can create a new project. And it shows you essentially different ways of organizing your work. So if this is going to be a highly collaborative piece of work, I would say a team planning type of board is great. And so it has columns like to do, in progress, and done. And it has cards that you can move to see what people are working on after the issue has been assigned. There is things about future releases. So basically, when do you think you're going to hit a point where you're happy with your code and you really want to take a snapshot of that code? And there are very different ways of doing it. There is the bug tracker. So if you have a lot of bugs, like label, it will allow you to do this. Or you can start from scratch and create your own. So even when I work alone, I tend to do the team planning one because I like the to do, done, and what else to do. Or you can use whatever you want. So I don't know, let's do a board and say Coral visualization organizer for a GU meeting. How is that? And then you can say create project. And if you do this, it's going to do to do, in progress, and done. So let's say that I'm interested in fixing one of my issue. I can add an item. So I'm going to type the hashtag so that I get the repository. Click on it. And then it's going to search for the issues in my repo. So add instruction. And so now it's on that to-do list of things that I have to do, and I can organize myself essentially on how I want to do it. Does that make sense? Yes?
So why use this more than any other project management platform?
Couple of reasons I tend to use it. First of all, it keeps everything in the same place, like you're on GitHub. And so it keeps track of the things that you're doing on GitHub. So see, I just clicked on stuff instead of actually having to write in another program management platform, the things that are on GitHub and link to it. If you're working collaboratively and everybody is on GitHub, it allows you to really work with other people a little bit more. So if I show you the linkters one, where there is more of us, we now all have access to it and we can all see what's being done and so on and so forth. So basically this is assigned to me. Actually, funnily enough, I finished it, but I could actually move it to in progress and signal to my collaborator that I'm actually working on it actively.
And is this also in the GitHub desktop app?
I don't think it is. I think it's mostly on the GitHub UI on the website. But PaleoClean, I cloned it to my local repository. And so to my local machine, sorry. So I have a repository that I work on.
Okay.
But that's basically what you can use it for. you can also create milestones for yourself. So if I go back to my issues, I went too far. You have something called milestones. And so you can create a milestones, which could be, I don't know, AGU for meeting poster. Put a date on it. So when is AGU? December? December 8th? Yeah. Steps that needs to be worked on for the AGU poster or paper or whatever you want. Create a milestone. And then you can add issue to your milestone. And so to do this, go back to the issue, go back here. And now in the milestone, I can add it. And if I do this and I go back to my milestones, now it's going to show that I have one open. And it's going to show you a list of things that you have to work on. And again, the advantage here over other platform is because you're working on GitHub, your code is on GitHub, you're opening the issues, everything is linked and stayed together. Much more useful when you're working with other people too. That's a little about how to use GitHub for project management. So now let's see how we're going to fix our issue, which is just to add instruction on how to run the code on a local machine. So this is where, as I mentioned before, for this demo, we're doing an overkill so that we show you how GitHub works, but this is really an overkill. The reality is if I was doing this, I would just click on this little edit and I would just directly edit from here. I wouldn't even go on my own local computer. But when you have issues where you might want to preserve the code that's on the main branch, or it's going to take you a little bit of time to work on it, things like this, what you might want to do is create a branch. So when to create a branch? Some of the things definitely where you want to create a new branch is if you're collaborating with somebody in the same repository, definitely work on your own branch so that you don't actually interfere with people. And the main branch stays basically untouched until you're 100% sure that the code is working. You might also want to do this if, let's say, you're creating a fairly complex model, like let's say a hydrology model, and you want to add a module to your code. You might want to create that module on a new branch that doesn't touch the old model until it's ready to be integrated, essentially, and it gives you a little bit more time. I tend to do it to keep track also of what I'm doing a little bit, because there are automated things in GitHub that allows you to keep track of what was done when you do pull request. So I'm going to do an overkill here, but I'm going to create a new branch to address that issue. So you go to main. You can also do this in desktop, and you say, I don't know, you call it something that basically makes sense for the name. And then you say, I want to create from main. So essentially, now you have two branches. And what's happened is install instruction took a copy of what was on main and put it in its own branch. So far, so good. And it's telling me that that branch now is up to date with main because we haven't done anything to it yet. So now if I go back to GitHub desktop and I fetch what's on GitHub. I have my current branch is still main, but I can switch to install instruction. And so if I go to my local files, it's going to show me the local files for the instructions. Yeah. Okay, so I'm going to add the instructions. And save. And so now it's telling me, like before, that there is changes to my README. I added text. And it's ready to actually go on GitHub. Now, let's say that, okay, I added the text, but something, I want to work on the main branch back. If I go back to main, and I'm going to leave it for now, switch back the branch. Then if I go back to my file, see, it doesn't have the instruction anymore. So it's keeping basically two versions of that file on your own machine. So if I go back, I go back to my stat changes, I restore them. So now it's back. I can say, I'm going to leave update README as the title, going to commit and push. So now, if I go on GitHub, it's going to say that I have 2 pushes and I can compare and do a pull request. So if I click on it, so you can do it this way, or you can go to pull request and create it. You can also do pull requests from GitHub Desktop. And that's where I usually don't do it from GitHub Desktop because I actually like the GitHub interface that tells me that little directional arrow that what I'm putting is what's in here and I'm putting it into the other one. And that's a preference. A lot of people do it either from the command line or GitHub Desktop. It's just I've made the mistake before of pulling the wrong way, and it takes quite a bit of time to actually undo essentially all the changes that you erased. So personal preference, you can do it many, many ways. But then you can add a title to your pull request. So this one could say update README and say I added instructions on how to install the notebook to run on the local machine. Make sense? And then in this case, it tells me it's able to merge, that there is no conflict between the two. If there are conflicts, it's going to tell you it cannot do it automatically, and it's going to ask you to resolve it by hand. And conflicts usually happen when, you have 5 or 6 people working on the same repository. You basically created a branch for yourself from the main branch. Somebody else did the same. They changed something, put it back into main. And then now you're out of sync with that main as well. And so you can create conflict this way, like by having multiple branches. What you can do is ask for somebody to review. So if you're working with somebody else in that repository, and if you're working on collaborative code, it's always a good idea to ask for somebody to review what you've done, to make sure that it's up to standard or it's working properly. You can actually label and see which milestone it corresponds to, which project it corresponds to, and so on and so forth. So you can actually do some project management. You can actually also say something like closes number, and then it will show you the issues, and you can say closes number 4. And it will link back to that issue as you do it. Create the pull request. It's going to check again that it can merge automatically. It's telling me there is no conflicts. Feel free. Merge. Confirm the merge. And then if you're happy with it and you don't want to reuse that branch for anything, you can delete it. You can always restore them too. So again, for what we just did, that's an overkill, but it's just to show you how to use branches in pull request. In practice, you're going to use them mostly for things like I'm working with other people, or for things like I am not really ready to mess with the main code yet because I want to use the main code for something else, but let me experiment with something on that other branch. Sometimes it's useful when you have a meeting, like a collaborator meeting or a meeting with your advisor, and you're like, okay, I'm not ready to share this with my advisor yet, but we want to be looking at results. So I keep a version of the notebook that I know runs. We can have discussion with my advisor. We can have discussion about the projects. But the changes that I made that are not ready to be seen yet on another branch, and we're not even discussing them today. And then again, like I tend to use GitHub for everything. And so if I had a meeting with my advisor, I would probably open issues as we talk so that I can fix essentially the code. And so far, everything I've shown you, you can do it on a private repository as well. So if you want to keep that private, you could. Dave, you were about to say something.
Yeah, I was just going to add that this whole process also works for repositories that you are not collaborating on, you don't have write access to via a fork. So a fork is a branch of a repository that you do not have access to. So you can create a fork, which is analogous to a branch, but this will be on your own repository. This fork will be a copy of the original repository. It links back to the original repository and tracks the changes from that original repository. But since you don't have write access, you cannot create a branch there. So if you go ahead and create a fork and make changes, you can create a pull request in a similar way, but somebody else who does have write access to the original branch would have to merge that pull request for you.
It's also useful when, if you're a new graduate student or you're actually an older graduate student, there is new graduate students coming into the lab. For them to have access to your code, they can actually fork your repository without actually working with your files directly. So there is many uses for this. So far, so good? Yes, correct.
Maybe a more bedrock question outside of the GitHub desktop, but like for actually doing it like from the command line to say like your GitHub repository, is there a step where you have to somehow like connect your computer work environment to the GitHub repository, some kind of like login or connection type thing?
Yeah, and that's going to depend on your operating system as well, because GitHub changes authentication. And we can link to you the GitHub documentation. I'll be honest with you, if I were trying to do it again, because it changes almost every year, I think last time I did it was very different than what you have to do now. But yes, you're gonna have to authenticate, and then you kind of have to put your credential if you want in a file that's hidden on your computer so that you don't have to do it every single time. And there are ways to do that.
Okay.
It's been a while for me, so it's one of those, once it's done once, you don't have to redo it.
Yeah. I
But
just know the
even for GitHub Desktop, I think the first time it's going to ask you for your credential.
yeah, I've had the GitHub desktop for Linux is not really officially supported, so I think if I'm going to fully integrate this, I'll need to set it up just through my terminal.
Yeah. Yeah, we were trying to avoid this for most people. Desktop actually works pretty well. All right, so the last part to it is essentially a concept that's called releases. And so what that is, it's basically saying, I'm very happy with my code. I want to take a snapshot of it so that it gets into a tarball and keep it essentially alive as a snapshot. So that's what a release is. So the question is, when do you do a release? Usually, if you're working with software, like you're creating a new software, think about like major updates that you're doing with your code. So if you're creating a model, hydrology model, for example, you have a new module, new functionalities, that would be a release. If you're working with software that has multiple bugs, you could actually release every time you fix a bug so that it actually gets on PyPy and people can install, or CRAN, so that people can actually install the right version on their computer that's bug-free. If you're working with workflows, usually your first release would be when you submit the paper. And then you're probably going to be a few releases after this for all the reviews. So if you go through review process twice, you would have 2 more releases after the initial release. Make sense? Okay, so before you do the first release, and I'll show you how to make the second release from this, what you want to do is link to Zenodo so that you can get a DOI. And what's going to happen is every single time you ask for that snapshot to be taken, so for that tarball to be formed, it's going to put that tarball onto Zenodo so that people have access essentially to that snapshot. Yes? Conceptually? Okay. So 3 steps to do this. The first one is to create that file called citation.cff. The best way to do it is to find a repository that has it, copy that file for your own, and make it. What it does contain is basic information about the package. So the CFF version, a message, and I'll show you where that message is, but if you want to use this tutorial example or if you want to use this software, please cite it as below. Put the authors, and again, your name, first name, and if you have one, and you should all have one, your ORC ID, your unique identifier. Give it a title, give it a version, and to version code, there are 2 good options that people use. The first one is something that says 0.0 point something. And the way it works usually is the last number are small bug fixes. The middle numbers are actually big implementations within the code that changes some of the features, some of the functionality. Like, for example, you have a code that does visualization and now you're creating a new dashboard. That would be a good use of that second number. And the first number is you're making so many changes to the API and how people call your code that chances are you're going to really break a lot of legacy code when you release that new version. So when people use that nomenclature and you see 2.0, you might want to wait until 2.0, 0.1, 0.2, 0.3 before you actually change your code because they're fixing all the bugs. Like there's going to be a lot of bugs. If you have any Apple products and they tell you wait until you install the new iOS, that's why. Like they make so many changes that things actually can break. The second way of doing it, which is what I've done here, is to actually just use a date format. And usually it goes year, month, day. And it actually kind of tells you when the thing was released. When did you release? Are you releasing it? What's the URL of the GitHub repo? And this is where there is a chicken and the egg question here. The first time you do it, you don't have the DOI. So you leave that blank. Well, actually, you remove that line the first time around because you actually have to go on Zenodo to get that DOI. And that's where things get tricky. When you change the citation.cff file, it can never have the same version number. So every time you make a change in that body, you actually need to change the CFF version. So what I usually do is I use the same version number as the code, and then I add one more number that is just for that CFF file. There are ways to automate this through GitHub, through Actions, if you want. But that's basically what those automated actions do, is making sure that you're updating that citation file. And that citation files get used two ways. The first one is, this is what it gives you: cite this repository. And you have an APA citation or a BibTeX citation that people can copy to cite you. And the second is when you actually link to Zenodo, it's going to use the information in your citation file to create the basic information on Zenodo. Make sense? All right, so Zenodo. So if you don't already have an account, the easiest way is to sign up through GitHub with your GitHub credential. Otherwise, you're going to have to link your account to GitHub, your Zenodo account to GitHub. Once you've done this, if you click on the right-hand side on your name, you can go to GitHub. And then what it's going to do, if it's actually synced, it's going to show you all the repository that you have access to. So something I haven't really talked about yet, you have your own account. So everything that I've done so far is on my own account, but you can also be on a organization account. So when you see things like EarthCube or Linked Earth, it's an organization account. And we have many repositories under that, but everything is going to show up. And then it's as easy as following those instructions. You flip the switch, you create a release, and you can get a badge. So for the call one, it's already flipped because I've done one somewhere. There you go. So it's already flipped, it's on. And so my next step would be go back and create a release. So I can create one since we did some changes. So I'm going to draft a new release. It's asking you to choose a tag, and usually I use the version number. Actually, let me do something, which is change the version number in my citation file. What's the date today? 12? Go back to this, draft a new release. So V2025-02-12. I'm going to create this on publish. You can put a release title. You can either use the version number, or you can put a name, or you can do both. Demo release. And then you need to describe this release somehow. So you can say, just adding instructions. If you use branches, you can get a lot more details, because you can say general release notes, and it's going to generate things that were done every time there was a pull request automatically for you. So it's going to tell people what you've done. And also give a link to that full change log. And then publish release. Once you've done this, Zenodo will actually give you a DOI. So if I go back to my repository, See now, that was the initial release. This is the new release as of like that I just did now. And see, it has a slightly different DOI. And I think I talked a little bit about this yesterday. What Zenodo does is that it mint a DOI for every single release, but it also gives you a DOI if you want to blanket all of the versions under it. So if I go to it, it actually gives me that snapshot now of all the files that I did during the release. And it also is giving me a citation and a DOI. And I forgot what the DOI here. See, each DOI is attached to a version, and it says you can use this DOI if you want to cite all the versions under it. Questions? And yes, to do this, the repo has to be public. Sorry. Okay, so you can do everything through GitHub and everything automatically. If you're not happy about it, you can always go back and edit into Zenodo. So you can add information, you can add creators and contributors, for example, if you didn't do it properly in GitHub in that citation file. Instead of what has changed, if you're not happy with the release, you can change that as well. You can give additional description. You can add essentially keywords, languages, basically everything that you might want to add. Something that a lot of funding agencies would like you to do is to add the funding to this. Once you've done it once, it will keep it in mind. So you can actually edit for the resource as well. So you're not stuck with only what GitHub has done. You always have full control on Zenodo as well. And then if you go back a few steps, if I click on the badge itself, it gives me the markdown code for it. And then I can go back into my README and add it. That's what I did last time. So just click on this and add it at the top. So that's how I got the badge. Good?
Do you have an easy way to avoid action being put as an author in Zenodo? When you have a GitHub action in your repo and when you create a release, the GitHub action itself is created as an, and so I usually go in and manually delete that. But I was wondering if you have an automated way of it's saying that do not use anything automated like GitHub Actions as an author.
Does it do it when you have a citation file? Because I've never had that problem, and I have quite a bit of GitHub Actions on a lot of my
Oh,
repo.
maybe, yeah, maybe I didn't use the CFF, so I didn't know that was a way to avoid it. But that's good to know that. So if you have multiple authors right now, how would you modify the CFF?
Sure. So let me show you on that one since it has a multiple authors like this.
Nice. Can you share this link?
Sure.
Thank you. Yeah, I've had that actions thing, but again, I didn't know that with CFF you can force the behavior to not include those as authors, which is great.
Yeah, actually, funnily enough, this repo that we just did has an action in it because we're going to use it tomorrow for my binder and not my binder for creating a container. And so the CFF basically says ignore the action. See, there is an action in it that also got triggered automatically. And we'll talk about this tomorrow, how to do this. There are GitHub actions too to automate the CFF thing to avoid having to manually, change the version every single time. I never got them to work the way I wanted, so I just do it manually. Any other questions? Okay. How about we take a short break?
Sorry, quick question. Yeah, does the edit now allow for deleting once something has been released? I know that last time I had to do this, I had to email Zenodo to get something deleted. If you accidentally commit, for example, credentials, and you want to delete that release, what's the easiest way to do that?
Contact Zenodo.
Okay. Good to
Yeah.
know.
Um, yeah, I was gonna say be careful with releases because once you release and you link to Zenodo, and if you have a lot of actions that are done once you release, it's hard to undo. Well, so the credential, was it a file or was it a,
It was an API key.
but it was in a file, right?
Yeah, it was in a file, and then I basically contacted them, and then they kind of like retracted the release. The nice thing is, I think someone showed me that you could theoretically embargo a specific release, and that would allow you. And I was like, I don't actually know how that works, because if you embargo one release in the whole path, then it would automatically mean that the next ones, I don't know if the next ones will be automatically public or not. The easiest way was to actually email them and change my API key.
Yeah, there is a few things too with Zenodo when you do this is apparently only one person can do this on the repository. So if that person basically leaves
Mhm.
and you no longer have access to the Zenodo because they don't allow for multiple people
Mhm.
to have that privilege of adding things. Um, like there's a lot of things where you actually end up having to email them because they're,
Yeah.
I mean, it is meant for this, right? This is what they're supposed to do is preserve something for perpetuity. So
Mhm.
they don't want somebody to go and say, hey, please delete this because I made a, I,
I made a mistake or something. Sure.
and they have to make sure it's really you and not somebody else, essentially.
Yeah. I mean, it's the same with like GitHub logs, right? I mean, theoretically, even though you can try to delete them, there's always ways to retrieve those. And if you have committed a credential in there, theoretically, someone can go and look at the diff files and search for credentials.
So, it's one of those things where this is why yesterday I was like, if you're in case two, be very careful to do it before you commit anything because you can always track it back on GitHub. It's hard to remove stuff. And that's the point of it. It's transparency. All right. So do we want to take a short break? And then when we get back, we can all try to give it a try with your repository and see what happens. Good. 10 minutes? 15 minutes? 10? How about we get back at 10:50 a.m. So it's 10:40 for me, 10:50.
Great.
That's good.
I will have to head off, but
Okay, so this is not going to take very long. It's more about the afternoon, what we're going to do. So the first thing would be if you're in Python, you can fork my repository if you rather do R. You can actually use Dave's repository. Let me put the link in the Slack. Uh, right, I'm just gonna put Python and I'll let Dave do the R. But basically fork one of the repositories, doesn't really matter which one. Open an issue on that repo, on the original one, so on mine or Dave's. Fork the repo, answer the issue, just do something small. And essentially create a pull request asking us to review it and merge it into our repo. That's the first exercise for today, so that you get, some practice in merging and pulling and things like this. The second exercise for today is to use your use case and essentially go over the step that I did over the demo. So create essentially a README that people can reuse, create a repository create a repository, create a README, choose a right license, put the information that you need into your repo, create a citation file, and link to Zenodo, do a release, get your DOI, update the README. Can't hear you, Kurt. Is it just me or?
Yeah, I can't hear him either.
Oh, did that work?
Yeah, okay.
Oh,
Zenodo.
apparently just staring at my audio settings is the magic.
Yes, so basically yesterday's homework was grab all your stuff, put them in one place, but not necessarily on GitHub. And so today's assignment is move, if you've already done that, that's fine.
Oh, okay.
Move everything to GitHub and do all of the citations, Zenodo, and so on and so forth.
Gotcha.
And
And
if you want us to review anything, let us know. If you have any problems, let us know.
okay.
And we can do this. The second part to this, and this is why I was asking Marion to put her test repo into Slack, is help each other and open issues on each other's repo.
Okay.
And same thing, if it's something that you see an issue, but that's something you can fix, fork, correct, and open a pull request for her so that she can also get used to how to merge on her own repository on the other side. So basically help each other in this case.
Okay.
And
Nice.
yes, it can be something as simple as add a comma. It's just the practice of it, not.
Yep. Great.
If you want a code review, we can help you with this, but this is not the main part of it. So don't worry about the code for now. In
Yeah.
theory, if you're using GitHub, it's more for the code. But
Yep.
in this, let's keep it simple.
Mhm. Okay. Probably gonna try to restart Zoom. Things just seem to be getting weirder and weirder on my end.
Feel free to reach out if you have trouble. Oh, never mind.
Yeah. And then Sam, do you have any questions? All good? Not back from bike. And I'll put some instructions on Slack. That's what I was going to finish, and I think we're good for today. If there are no questions, we're
Yeah, I
good?
was just going to throw in for Kurt, if you have trouble connecting RStudio to Git or using Git from the command line in Linux, feel free to reach out.
Great, thank you.
Yeah.
And something I meant to ask, you can add a license after creating the repository?
Yeah.
Okay, great, thank you.
If it's private, that's not an issue. If it's public, you might want to have a license set from the get-go.
Okay.
All right, well, if no other questions, then homework for today is just finishing that repo, linking it, getting practice on pull requests and so on and so forth. And tomorrow we'll do containers, GitHub Actions, containers, and my binder.
I was going to say one thing specific to licenses for R people. We'll be using Rocker, which is an organization that puts out containers specifically for R. And using their software, they have a copyleft requirement. So you'll probably have to use the license that I've used in those example repos I've shared,
Okay.
or something pretty similar to it. The GPL2 license is what Rocker uses, and yeah.
Cool. And for, I guess, of the like RStudio Git thing, you can do that on you can still use like a repository that has like, also some Python scripts and stuff. You just will use the actual Git functions through like whatever R script you're working on in RStudio.
Yes. So
Okay.
the RStudio GUI just happens to cover the Git commands. So it doesn't matter what kind of code is in there. There may be an automated aspect to what sort of git ignore file is created if you start it from R.
Okay.
So it'd be worth taking a second look at the git ignore file.
Sure. And then for using Rocker tomorrow, do we need like Docker or like Docker like command line or Docker desktop installed like to run it?
So we'll interact with that via GitHub Actions. So
Okay.
all of that will happen in the cloud. If you want to get more granular with building Docker files, it would be useful to install Docker Desktop, and that would also allow you to run the image locally.
Okay.
Run the container image locally. So yeah, it may be something you want to spin up if you're going to be doing more with containers.
Okay.
But it's not a requirement.
Okay. Yeah, I'm using like an immutable desktop. So if it needed like like some Docker things need like root access, which isn't great. So I've used like Podman or something for my brief intro to containers, which is a little more forgiving for that. I just wanted to check before we started doing the tutorial and realized I couldn't do it on my own computer.
Yeah, you should be able to do everything from Podman as well. I think.
Great.
But also, at least for the Python side, it's GitHub Actions. So it's not, you're not actually building the container on your computer. So you don't need any containers to be installed, like containerization software, because GitHub will do it.
Okay. Great. Thank you.
All right. Well, see you all tomorrow.